Today we're going to cover section 6. We're going to see the next two trig ratios. It's going to be the sine and the cosine ratios. So here they both are. This time we're going to be using the hypotenuse today. Remember, the hypotenuse is always going to be opposite the 90-degree angle. So for the sine function, you're going to be doing opposite over hypotenuse. And for the cosine, and that's what's written here. They're just, writing it out longer. So cosine, we're going to be using adjacent and the hypotenuse. So again, you're going to need to identify the three different sides. Always label the hypotenuse first, and then go back and put in the adjacent and the opposite. So based on the angle you're looking at, it's going to have a different fraction. So for example, if you're referencing angle A here, notice the sides that are opposite and adjacent. Opposite to A is little a, and adjacent to A would be the B, and C is going to be the hypotenuse, no matter if we're talking about A or B. Now, if I were talking about angle B, and I'll do that in red, opposite to B is going to be the B, and adjacent to B is going to be the A. So you have to look at it based on the angle that they tell you to look at. So now we have three trig ratios. We've got sine, cosine, and tangent, and that's where that SOHCAHTOA comes in. Okay, so in the next slide, we're just going to talk about this acronym. Okay, this acronym is going to help you remember the three trig ratios. So the beginning one, the SO, that's for your sine. And remember, the O is going to represent opposite, and the H represents the hypotenuse. Then the next trig function is ratio is the CA, which is the cosine. The A represents adjacent, and the H represents hypotenuse. And then the last one, the tan, which we saw yesterday, that's the TOA, and that'll be opposite over adjacent. So if you remember SOHCAHTOA, it'll help you remember the three trig ratios. So that's all we're talking here. This is a really handy-dandy acronym. You could probably go home, and if your parents took any math in college, they might remember SOHCAHTOA. It's never really in any textbooks, but everybody knows about it. So if you talk to anybody, they know SOHCAHTOA. All right, so the next slide has an example on it, and it just wants us to write or express each one of these as a fraction. We're not going to divide it like we did in last night's homework. They want us to leave it the fraction. So for the sine of A, let's go ahead and let's label the sides based on each angle. So first thing I'm going to do is I'm going to find where angle A is. The next thing I'm going to do is label my hypotenuse. The hypotenuse is going to be the same whether it's A or B. The hypotenuse is always opposite, or the biggest side, opposite that 90-degree angle. So when we're talking about angle A, which number is opposite A? 3. Okay? So for these three trig functions, these are going to be the names I'm going to use. So for the sine of A,
why do we use the letters?
For what? For the angles, you mean?
Yeah, like for sine, A, why would we use B over C? Like, letters instead.
Because the letters right here in this picture are for the angles. And when we're putting them into the fraction, we use side lengths. Okay, so for sine of A, I need which two sides? What does sine use? Opposite and hypotenuse. So for the sine of A, all I'm going to do is put 3 over 5. They told you to leave it as a fraction. Then for the cosine of, or no, let's keep doing sine. No, we're doing sine, sorry. Cosine of A. Which two sides use cosine? Adjacent and hypotenuse. So that one's going to be 4 over 5. And now we'll do the last trig ratio, the tangent of A, which uses opposite and adjacent. So the tangent is going to be 3 over 4. So when it says to write or express the sign of a particular letter, and it says leave it as a fraction, all we're looking for are the correct sides, either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Now let's reference angle B. I'll do those in blue. So in reference to B, the hypotenuse is still the same. So this is still the hypotenuse. Which side is opposite of B? Okay, AC or the 4, good. And then the adjacent is going to be the one that's left, which is going to be the CB or the BC, and that's going to be 3. So now sine of B is going to be what? What's my fraction? Opposite over hypotenuse, so it's going to be 4 over 5. What's going to be cosine of B? Bella?
3 over 5.
3 over 5. And lastly, the tangent, which is going to use opposite and adjacent, and that's going to be
4 over 3.
4 over 3. Okay? We will never do trig functions or trig ratios for the right angle. Only the two acute angles. Okay? So this is why we're not doing sine, cosine, or tangent for C. Only the two acute angles. Next one, we have another example. Now we're using our calculator. Now remember, when they just ask you to use your calculator and find the sine or the cosine or the tangent of an angle, most calculators you're going to hit sine and then the number and then either enter or equal. Other calculators you have to put the 30 first and then hit the sine button. Okay? And for this one, anybody have the sine of 30? Okay, 0.5. Good. What about the cosine of 42? So in your phone, you're going to hit 30 and then sine. All right, let's make sure you're in degrees. So cosine of 42. Bella?
0.7.
Okay, and if you put out more numbers than that, you should have gotten like 7, 4, 3, 1. It didn't specify, so because the one above it was to the tenths, you could have said 0.7. All right, next one, this is where we're going to do the -1. So on your calculator, this is where you're going to hit the shift key. So whenever you're looking for an angle, you're either hitting the second key or the shift key, and we want it to be sine -1, and then we'll put that decimal in there, and then hit enter. What'd you get?
6. I got like 5.99.
Good. So we're going to round to the nearest degree. So right now it should be like 59984. So rounded to the nearest degree would be 6 degrees. Anybody get cosine? Okay, good. 15. Because that ended up being like 15.0057. Okay, so rounded to the nearest degree is 15. Okay, so when you're doing questions like this and it tells you to use your calculator, just watch the directions, okay? If it says give it to 4 decimal places, or if it says tenths or degree, just read what it's asking for. And also, whenever you're looking for an angle, then you're going to use that shift key or the second key on your calculator to get an angle measure. Everybody good on this slide? Okay, example 3. We now need to find the values of x and y. And notice the instructions say to the nearest integer. So basically we're turning it into like a whole number. No decimals. Okay, so now, first thing we're going to do is find the angle that's labeled in the picture and not the right angle. We want the acute one. So right here we have 28 degrees. So now, I can do different trig functions here to find these values. But let's go ahead and let's label the sides based on the 28 degree angle. What is the hypotenuse? What on this picture? The 1,000. So I'm going to label this as hypotenuse. Okay? In relation to the 28 degree angle, what is x?
The opposite.
Opposite. And then the y is going to be our adjacent. Okay, everybody with me right now? All we've done is label our picture based on the 28 degree angle. All right, so now we've got to figure out some trig functions to find x and y. Which one do you want to use to find x? Okay, we're going to do sine because that uses opposite and hypotenuse. And I can only have one unknown, and my one unknown is the opposite. So I'm going to do sine of 28 is equal to x over 1,000. Everybody with me on that? And then just like last night's homework, we're now going to solve for x. We need to get the 1,000 out of the denominator. So we're going to multiply both sides by 1,000. Cancels out of there. And our final answer is just going to be the sine of 28 times 1,000. Okay. Yeah. Okay. What I needed to do is figure out which trig function, either sine, cosine, or tangent, I'm going to use to find the value of x. I noticed that the sine trig ratio uses opposite and hypotenuse. So I'm going to set up my trig ratio for sine, which is opposite over hypotenuse. My opposite in this picture is x. My hypotenuse is 1,000. And I'm using angle 28. So now on my calculator, I'm going to do 1,000 times sine of 28. Once you do that, you should get 470. Now, you might think 470 is kind of a big number, but look at the size of our hypotenuse. It's 1,000. So 470 for this leg is reasonable. Does that make sense to everybody? All right. Now I need to find y. How could I find y? I could do Pythagorean theorem. What else could I do? I could also do a trig function. Okay. I could do, how about cosine? Okay. Because tangent, let's see, tangent, we could do tangent. We can do more than one here. Okay. So since we're learning about sine and cosine, let's try cosine. So let's do cosine of 28 is equal to y over 1,000. Because y is the adjacent and 1,000 is the hypotenuse. So for this one, when we go to solve it, we're going to multiply again both sides by 1,000 to get it to cancel. So I'm going to do cosine of 1,000 and multiply it, or cosine of 28 times 1,000. And what do you guys get? Good, because you're going to get 882.9. And we're going to round it to the nearest integer, so we're going to make it 883. And again, 883 is reasonable, because as long as our hypotenuse is bigger than the other two, it makes sense. We could have also done Pythagorean theorem here. But if your instructions on the test or the quiz say use a trig function, then we do that. Okay? But as long as we have two sides and it's a right triangle, by all means, you could use Pythagorean theorem. Okay? If it just says complete the triangle, then you could use Pythagorean theorem. You could use whatever you want. If it said complete the triangle, the other thing we would have to find is this angle over here. How could we find that angle? If it said to finish it up. I know there's not a letter there. Good. I could add 90 plus 28 and subtract from 180. Also realize that these two are complements, so I could also just do 90 minus 28. Okay? So if you have two angles already, know that you can just add them and subtract from 180. Everybody good on this one? Next one. Find x correct to the nearest degree. So again, we're going to round this to the nearest degree, the nearest whole number. So we're going to find our angle we're referencing. This is where we're going to do that -1 because we're looking for an angle measure. Let's go ahead and label what we have. What is the 30? Hypotenuse. What's the 18? Good. And I'm talking about in reference to x. Okay? Which trig function or ratio uses opposite and hypotenuse? The sine. So I'm not going to tell you which trig function to use. You have to look and see what numbers are given or where your variable is and decide which one to use. So what we're going to do here, we're going to set it up as sine of x is equal to 18 over 30. Now, when we're trying to find the angle, this is where we're going to do that shift key or that second key. And then we should, on our display, bring up sine to the -1. And then you're going to do 18 divided by 30. Once you do that, you should get 36.8. And we're rounding it to the nearest degree. Okay, did you get the -1? You need to hit the second key to find. Okay. So you should be getting 37 degrees. Let's see. Okay, so let's go ahead and do, or you have to divide first. Anybody else getting error? You're going to have to divide this first, so do 18 divided by 30 equals, and then hit the function. All right, on some calculators, you may have to do 18 divided by 30 equals, and then hit the sign, or the shift sign, okay? All right, does that make sense? All right, so then after you hit that shift and sign, or second and sign, you should have gotten 36.8, and we're going to round it to the nearest degree, which is 37 degrees. Okay, now, remember when we're doing trig functions, what kind of triangle do we need? A right one. I need to draw in an altitude to create two right triangles here. Okay? So I'm going to draw in an altitude straight down. Okay, it's going to be my perpendicular bisector. So it's going to create this leg to be 2 and this leg to be 2. And notice it's isosceles. So because it's isosceles, we don't have to really worry about the angles. All we had to worry was finding the hypotenuse and drawing the right angle in here. So we're going to label the 5. So right now, all I need to worry about is one of the sides. So this could be A, C, and I could call this D, where I drew my altitude. So this is 5, this is 2, and I don't know this. Okay, but it's saying find the measure of the 3 angles, round to the nearest tenths. Okay, so it's isosceles, but I don't know if it's a 45-45. All I know is it's isosceles. Okay, so now, what trig function could we use? Let's first let's find which angle you want to find. Let's find C first. Okay, so we're going to find this guy over here in the corner. What sides do I have? Let's label the picture. Okay, what's the 5? Hypotenuse. What's the 2? In relation to C? Adjacent. And then this one's going to be my opposite. So in relation to C, we're going to look for C first. What trig function is going to use some of these numbers that I have? 2 and 5. Which one uses adjacent and hypotenuse? Cosine. So I'm going to do cosine -1 because I'm looking for angle C. And then in my calculator, I'm going to do 2 divided by 5. And you should get 66, and we're going to round to the 10th, so 66.4. Does that make sense? Yeah. Okay. Now, what do I know about angle B? If my original triangle is isosceles. It's the same thing as C, right? Because the angles opposite the congruent sides are congruent. So I know angle B is also 66.4. Is that making sense? So this angle is 66.4, and so is C, 66.4. Now I don't need to worry about D. I know that's a right angle. I need to find angle A. Do I need to do another trig function? No. What can I do?
You can take the other angles from 90.
Good. Or actually from 180. So I have to add 66.4 plus 66.4, add that together and subtract from 180. The whole big original triangle, not the little half on the side. Yes?
Why do you have to use cosine -1 if you find the number?
I'm looking for an angle because I had 2 side lengths. Yes? Yes. So I'm going to add 66.4 plus 66.4 and get 132.8 and then subtract that from 180. And I find out that angle A is 47.2. So A is 47.2. So now I have my 3 angles, 47.2, 66.4, 66.4. And that is your application now of not just given a right triangle, you create your right triangle. And that was the last slide. Any questions on the sine and cosine ratios? So again, if you memorize so, ka, toa, each group of 3 letters is one of the trig ratios. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and the toa opposite over adjacent. So each one of the letters starts the name of the side.